Hi everybody, in this video let's learn about how to find the first derivative by using the first principle. I have a curve over here. The red color straight line is a tangent to this curve at point P. I have a few chords here, PQ1, PQ2 and PQ3. Still remember how to find the gradient of a straight line. We use this formula, y2 minus y1 over x2 minus x1, right? When the Q is very close to P, the change in the value of y and the change in the value of x is very small. We can represent them by using delta y and delta x. Delta y is the small change in the value of y. Delta x is the small change in the value of x. Therefore, if I ask you to find the gradient of this chord or of this straight line PQ, we can take delta y over delta x, right? Okay, now you try to look at this diagram. When the Q becomes closer and closer and closer to point P, you will notice that the gradient of PQ will become closer and closer to the gradient of the tangent of this curve at point P, right? Therefore, we can say that gradient of the tangent at point P is equal to limits of the gradients of the chord PQ as delta x approaches 0 when it's very close to the point P. So we can write them. We can write this way because gradient of the chord PQ represented by delta y, delta x, right? This is the first derivative, but normally we do not write this way. We represent it by using dy by dx. If the question gives you y, you find the first derivative, that is dy dx. If the question gives you f of x, the first derivative we will write f prime of x. They mean the same thing, just represent it different way. This is dy by dx, this is f prime of x. F prime of x. First derivative. We also can call the first derivative as gradient function. Because the first derivative is a function for us to calculate the gradient of the tangents of a curve at a certain point. To find or finding the first derivative dy dx or f prime of x by using the ideas of limits is called differentiation using the first principle. Today we are going to find the first derivative using the first principle. Okay, let's try a few examples. This is the thing that we are looking for, limits of delta y over delta x as delta x approaches 0. Okay, this is the thing that we want. So we are going to change this gradually and eventually we want to see this thing. Y is equal to 4x squared. We want to find the first derivative. Actually, we can get the answer really fast by using a formula. But since the question asks us to use the first principle, we have to follow the requirement of the questions. We just let it be the first one, the first equation. So when the point moves a little bit, we can represent by y will become y plus delta y. And the x here will become 4. Okay, be careful, don't write this way. Don't write this way. But we have to write this way. X plus delta x square. Okay, so I'm going to expand this one. Y plus delta y. Okay, so delta y you have to be careful because it looks very similar to 8. This is 4. Okay, here just use a formula to help to expand it. X squared plus 2x delta x plus delta x square. Okay, now I just do some expansion, bring the 4 inside. y plus delta y is equal to 4x squared plus 4 times 2, you get 8x delta x plus 4 delta x squared. Okay, let me double check, correct or not. 4x squared, 8x delta x, 4 delta x squared. Okay, correct. So we let it be the second equation. Remember, we are looking for this one. We want delta y. So I'm going to take the second equation minus the first equation. 2 minus 1. I take this one minus this one. Y minus y, they will cancel out. Eventually, we only have delta y. Delta y. And 4x squared minus 4x squared becomes 0. So we only left this part. 8x delta x plus 4 delta x squared. Okay, now we got this. The second thing, we want over delta x, right? So we divide the whole thing by delta x. So here become delta y, delta x. So here you divide it by delta x, you will get 8x. Here you will have 4 delta x. Okay, delta x only because now we have square, right? That here is delta x squared divided by delta x, you will only left delta x power 1. Okay, now we got this. The next thing, we want to add this to both sides. Limit of delta y over delta x as delta x approaches 0. So whatever we do for the left hand side, we do this exactly the same thing for the right hand side. So 8x plus 4 delta x. Oops, my delta not nice. Okay, so delta x. Still remember, we normally do not write this way. We represent it by using dy by dx. Okay, how do we get the answer for this part? We are going to substitute the delta x equals 0 here, right? So 8x plus 4 times 0. Now, we got the first derivative. The first derivative, delta dy dx, is equal to 8x. Okay, so there's a way how we get the first derivative using the first principle. What does this mean? This is a gradient function. It means that we can use this function to find the gradient of the tangent of this curve at a particular point or at any point. Okay, let me show you here. Now, this is f of x equal to 4x squared. Okay, let me check around not my equation. Okay, 4x squared, correct. 4x squared. This is the first derivative, which is 8x, right? 8x. Now, you try to look at the red color line. This is a tangent at point A. Okay. Look at the coordinate here. When the point A, the coordinate is negative 0.5, 1. How do we get the gradient of this tangent? The gradient is negative 4. But do we need to find 2 points on this straight line to help us to get the gradient? We don't have to do so. We don't have to draw this graph. We can just use the gradient function, which is first derivative, to help us to get the gradient of the tangent at this point. You see, this is the first derivative, which is 8x, right? At point A, negative 0.5, 1. What we need to do is just take this negative 0.5, plug in here, times 8. And we will get the gradient of the tangent at this point, which is equal to negative 4. So how about I change the other value? Now the coordinate of A is 0.5, 1. The gradient is 4. Can you see it? The gradient is 4. How do we get 4? We just take 0.5, plug in the gradient function, first derivative, and we get the answer, which is 4. Okay, let me try one more. Now the gradient is 8. When the point A is equal to 1, 4. How do we get 8? We just take the x value. Every time we only take the x value to plug in the gradient functions to help us to get the gradient of the tangent. We take 1, plug in here, calculate, we get the gradient of the tangent at this point, which is 8. Okay, so that's why we call the first derivative as a gradient function, because it is a function for us to calculate the gradient of the tangent at a curve, of a curve at a particular point. Okay, now let's try the second one. See the same thing, we are looking for this. I just let this one be the first equation. Then the second equation, y plus delta y is equal to 3x plus delta x. This is the second equation. I take the second equation minus the first equation. Y and y will cancel up. Eventually, we only left delta y. Okay, this I just copy first. 3x plus delta x minus 3 over x. This is a fraction. If we want to plus or minus, we have to change their denominator become the same first, right? Times x times x times x plus delta y times x plus delta y. So we will get this 3x minus 3 x plus delta x. This is x plus delta x. Okay, this part, okay, how about I write over here? I times x, here I do the same thing. Here I times x plus delta x. Here do the same thing, x plus delta x. So eventually I will get this. Their denominator become the same, so I can combine them together. Okay, let me proceed. Delta y is equal to 3x minus 3x plus 3 delta x. Oh, sorry, this is not plus because negative, positive become negative. This becomes negative. And here we have x squared plus x delta x. 3x minus 3x, no more 3x. Now we only have delta y is equal to negative 3 delta x over x squared plus x times delta x. The next step, we want over delta x, right? So we do the same thing for both sides. Divided by delta x. Here I will get delta y over delta x. This whole thing divided by delta x, it means times 1 over delta x. So this and this will actually cancel out. Okay, so we only have 3x squared plus x times delta x. Okay, let me write over here. Last thing, we want to add the limit as delta x approaches 0. We do the same thing for the both sides. Limit, okay, let me write over here. The limit of delta y, delta x as delta x approaches 0 is equal to limit of this function x squared plus x delta x approaches 0. Okay, let me check again. Okay, correct. So still remember, we do not write this way, we just change this become dy by dx. And then here we can start to calculate. We just bring the 0 inside here, plug in the 0 inside here. So eventually we will get negative 3 x squared plus x times 0, which is dy dx is equal to negative 3 over x squared. This is the first derivative for this curve. It means that we can use these functions to calculate the gradient of the tangents at this curve, of this curve at any point. Okay? Let's try the last questions. Okay, now we have x power 3 here. Before I show you how to get the first derivative of this, let me explain to you this one first. Last time you learned about the Pascal triangle. Still remember 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on. Actually, we can use the Pascal triangle to help us to do the expansion. Still remember this. A plus B squared. How do we expand this? Using the formula, we get A squared plus 2AB plus B squared, right? Okay. You look at here, we have 1, 2, 1. 1 to 1 is actually here, right? When the n, so now I have A plus B power n, and the n is equal to 2, we use this rule. How about if I ask you to expand this one, A plus B cubed? You can do it this way. Later on you can try it on your own. You write A plus B times A plus B squared. And then this one you just copy first. Here, you expand it using this formula that you have learned before. A squared plus 2AB plus B squared. Okay, how about I complete it for you? You can try on your own first. Okay, now let me complete this one. A times A squared, you will get A power 3, correct? This one times this one, you get 2A squared B, and the last one again, you will get plus AB squared. Okay, now let's focus on B. A squared B. 2, okay, sorry, plus, okay, let me leave some space here. Okay, plus 2AB squared, 2AB squared, and the last one we get plus B cubed. Okay, now we just simplify it. We have A cubed over here, and then here you have 2. We look at the like terms. 2A squared B. Okay, here we have another one. So total up, we will get 3A squared B. Now we look for AB squared. AB squared. Here we have 2AB squared. So total up, we will get 3AB squared. And the last one, we just copy plus B cubed, right? We need to do a lot of the step. Then only we can get this one. If you remember, if you know how to use the expansion using the Pascal triangle to help you, you can get it easily. Okay, let me show the method. This rule is for n equal to 2. When the n is equal to 3, we use this rule. What you need to do is just like this. This is power 3, right? So 1, 3, 3, 1. You write 1, 3, 3, 1. You write this one first, and then copy A, raised to the power of 3, plus. Now the power of A will reduce 1, minus 1. A become power 2. And this is, here we don't have any B. You can think this way. Don't have any B, it means B power 0. This power reduce 1. This B power 0 here, right? If we add 1 here, but we don't have a right 1 normally. Okay, how about I show you this way. 0. Here we plus 1. And here, reduce some more. You will get 3A power 1. B, that's increase. Become power 2. And last one, the a will become power 0, b will become power 3, but we do not write this way normally. b power 0 we don't have to write, power 1 we don't have to write. Okay, this power 1 you don't have to write as well, and this one you don't have to write as well. And 1 we do not write 1, here also don't have to write. Okay, you try to compare this one with this one. A cube 3a squared b, 3ab squared b cube, exactly the same thing, right? So if you know how to use the Pascal triangle to help you, you can do the expansion here easily. Okay, let me show you how to use it to expand, to do some expansion here. Okay, let's let this one be the first equation, and then y plus delta y is equal to 2x plus delta x power 3. I'm going to use the method that I showed you just now to help me to do the expansion for this part. Y plus delta y 2 1 3 3 1 1 3 3 1 1 3 3 1. Okay, so here I put x power 3, x power 2, and I have delta x power 1. If you want, you can put a parenthesis here, plus, and x power 1 delta x power 2 plus last one is delta x power 3. Okay, let me double check. 1 3 3 1 power 3 power 2 power 1, and then this power 1 power 2 power 3. Okay, correct. So okay, let me 1 we don't have to write, 1 we don't have to write. Okay, so this one look nicer. If you want to write the 1 is okay, but normally we do not write 1. Normally when the coefficients of a variable is 1, we do not write it. Okay, now just bring the 2 go in. So 2x cubed plus 6x squared delta x plus 6 2 times 3 2 times 3 6x, this is delta x squared, and the last one is 2 delta x cubed. Okay, let me double check this, let it be the second one. Now, so remember we are looking for this delta y delta x. As delta x approaches 0, we are looking for this. So I'm going to take the second one minus the first one. So y and y cancel up. Eventually we only have delta y. This minus this cancel up. We only left this part. So just copy 6x squared delta x plus 6x delta x squared plus 2 delta x power 3. The next step, we want over delta x, right? So we just divide the whole equation by delta x. So here I will get delta y delta x. Here I will left 6x squared because delta x divided by delta x become 1. Here I will have 6x delta x power 1, and here I will have 2 delta x power 2. Okay, the last step, we add this one, this part, limit as delta x approaches 0 for both sides. So this whole thing we just copy. Okay. So remember what I told you just now, normally we do not write this way, we represent it by using dy by dx. Oh, I forgot to write the 0 over here. Okay, I'm going to represent this one by using dy dx. Here, I'm going to bring the 0 go in here and here. 6x squared plus 6x times 0 plus 2 times 0 square. So the dy dx is equal to 6x square. Okay. Okay, so this is the way how we get the first derivative by using the first principle. So you will see this formula in your textbook as well. How to use this one? Okay, let me show you quickly how to use this formula. So some book, because delta x sometimes is a little bit hard to write. So some book will give you this. It's actually the same thing. They will represent the delta x by letters. For example, we use h represent the delta x. 0 x plus h minus fx over h. Okay, let me check. Yes, you can use this one as well. Okay, let me show you how to use this formula to help us to get the first derivative for the first one. A, y equal to 4x squared. Y equal to 4x squared. The formula, the answer that we got just now is 8x, right? Okay, let's try this formula. We should be able to get exactly the same answer. Here, I'm going to change it become f of x. Now, f prime x, which is the first derivative as well, just will represent different way because this is f of x. Here I will write f prime of x. It means the first derivative of this f of x. Okay, I will just use this formula. Limit as h approaches 0. Here I will write f x plus h and minus f of x over h. Okay. Here I just copy this one first. Every step I need to copy this. We go back to the function that you learned in Form 4. If this is x, we put x here. If this is 2, we put 2 here. If this is x plus h, here we have to put x plus h, right? 4 times x plus h square minus f of x, which is equal to 4x squared over h. Now, okay, so this just do expansion. You will notice that it's actually very similar to what we did just now, just the step look a little bit different. X squared plus 2 x h. So how about I write h first? 2hx plus h squared minus 4x squared over h. Okay, so here you will get 4x squared, do some expansion over here, and 8hx plus 4h squared minus 4x squared over h. Okay, let me continue here. 4x squared minus 4x squared, no more 4x squared. Eventually we only have this. And when this both divided by h, I will only have 8x plus 4h, right? Now, I'm going to bring the h equals 0 inside here. 8x plus 4 times 0. Okay, you will get 8x. Okay, let me check my step. Yes, correct. So you see, we got exactly the same answer, which is equal to 8x. Okay, for this video, I just stop here first. See you next time. Thanks for watching. Bye bye.